Okay, I'm back, and now we want to talk about what are asteroids. And so there's a little nomenclature here that I want you to know about. And so, in general, an asteroid is going to be a very large object. So these things are hundreds of meters in diameter, up to kilometers in diameter, and they're just basically floating around in outer space. Okay, when they get busted, whenever they collide with other asteroids, the smaller fragments are going to be called meteoroids. And then when those go through our atmosphere, they then start to burn up and they get very, very bright, and then that's a meteor. And then when those little chunks land on the Earth, then they're going to be called a meteorite. So what are asteroids composed of? So some asteroids are metallic, and they are going to be composed of iron and nickel. Also, if you break open one of these asteroids, you're going to find that when the iron cooled, it made crystals. And so I'm going to butcher this name here, Widmanstatten patterns. So those are the iron crystals inside of that particular kind of meteorite. And they're composed of iron. And this is not surprising because inside the Earth, we have an abundance of iron and nickel. So it's not surprising that some asteroids are composed of iron and nickel. Okay, then you also have stony meteorites. So what do you suppose they're composed of? Stone. And they tend to be magnesium iron silicates. And they tend to be divided into two categories. So you have the kind they're called chondrites, and chondrites contain chondrules, which are small minerals that represent the original material that formed the solar system. And then there are some other kinds of meteorites that are called achondrites, A meaning against, meaning that they don't have any of those chondrules inside of them. And then you also have some kinds of meteorites are composed of both rock and iron. So where do they come from? What we think is that you start with an asteroid in outer space, and if it's too small, it doesn't have enough residual heat in the inside of it to start it to melt. And so then that thing is just going to be a jumble of rock and iron, and it has no layers to it. And so that's going to be the chondritic stony meteorite. Okay, on the other hand, let's say that you've got a bigger asteroid and it heats up on the inside of it just like the Earth did, and it starts to form layers. Remember that the Earth has a crust, and then underneath that it has a mantle, and then underneath that it has a core. So let's assume that this asteroid was big enough that it also got hot enough that it differentiated into a crust composed of rocky material, a mantle composed of denser rocks, and then a core composed of iron and nickel. Now, let's say that once it formed, it got hit by another asteroid, and then it blew it apart. Well, if the part that was the core landed on the Earth, then that would be an iron meteorite. If the part that was the mantle landed on the Earth, then that's going to be a stony meteorite. And if the part where the boundary between the core and the mantle, if part of that landed on the Earth, then that's going to be the stony iron meteorite. So that's where they come from. How big can an asteroid get? So you're going to get a kick out of this. So I want you to watch this video on YouTube, asteroid size comparison, And remember that an asteroid in outer space that is smaller than a refrigerator will not make it through Earth's atmosphere. It will burn up before it hits the Earth's atmosphere. But asteroids get much, much bigger than a refrigerator. So I want you to watch that video. Do it. Okay, did you watch it? Was that cool or what? So it shows you just how big these asteroids can be. How many asteroids are in our solar system? So here's a chart that shows the number of asteroids in the solar system versus the size of the asteroid in kilometers. And you'll see that most of the asteroids in our solar system are relatively small, smaller than a meter in diameter. And again, those are not going to survive a trip through our atmosphere. They're going to burn up due to the friction with our atmosphere. And you see, though, that the bigger the asteroids get, the less of them you have to worry about. But there's still quite a few of them that are planet killers, that are big enough that they could definitely cause a lot of damage if they were to hit the Earth. So how much damage can an asteroid do? So this is kind of like the Richter scale for asteroids. So it shows you, based on the diameter of the asteroid, how much energy would it give the Earth if it collided with it, and then how much damage could it do. So I will let you read that. Remember, you can always stop the video and you can expand it so that you can read anything on that chart there. And so I'd also like for you to watch this video on YouTube, see asteroid impact comparison on YouTube. And so this shows what it would look like if an asteroid, first it starts off with New York City. What would happen if an asteroid hit Central Park of New York City? How much damage would it do? And the asteroids get bigger and bigger and bigger and bigger until finally they're planet killers. So what killed the dinosaurs? Well, we think it was an asteroid. So approximately 65 million years ago, an asteroid 16 kilometers in diameter, traveling at 12 kilometers per second. So going at that speed, remember that if you were in Minneapolis, Minnesota, you can get down to Houston, Texas in 5 minutes going at that speed. So this object was traveling at about that speed. When the front end of this asteroid made impact with the Earth, the back end of this asteroid was up where airliners fly, 30,000 feet, 10,000 meters in the air. And it generated energy equivalent to 1 billion atomic bombs exploding. It blew so much dust into the atmosphere that it blocked out the sun, and then without the sun, the plants died, and then without the plants, animals which ate the plants began to die. So that most of the larger life forms died as a result of this collision. And they think that the collision occurred down in the Yucatan Peninsula, which is down there by Mexico. And if you go down there, you're not going to see a crater because that crater has eroded away. However, when they use seismic waves to probe the ground down there, they found this ring structure. And so that's an indicator for that was where the crater was. Asteroids have hit the state of Missouri too. So roughly 300 million years ago, an asteroid 0.45 kilometers in diameter hit North America, generating the equivalent of 53,000 atomic bombs exploding. But what happened was that as this asteroid traveled across North America, it began to break up. And so chunks of this asteroid peppered Missouri as it traveled across. And so in particular, up in north of Springfield, Missouri, is where one of these chunks hit. It's up by Osceola, Missouri, is one edge of the crater, and then the other edge of the crater is Humansville, Missouri. And so if you're traveling up Highway 13, you're not going to notice the crater. The crater has long since eroded. But if you look at that picture there, look at the rivers. Do you see what the rivers are doing? So that you've got, I believe that's the Osage River up there, and it is traveling like this. You see it's making that curve? And then over here there's another river system that's doing that. And then down here you can kind of see some hills that are kind of like this. And so that is the actual outline of the crater. For the longest time, nobody even knew that it was there. And it was farmers who were digging wells, and then when they would dig their well, they would be pulling up crushed rock. And that crushed rock was a consequence of the impact. Another interesting thing, if you go up to Osceola, is that you are going to find these things that they call Webelow eggs or Wobelow eggs. And they're not pieces of asteroid. So what they think happened was 300 billion years ago, Missouri was a shallow ocean, about 500 feet deep. And so when the asteroid came in and it hit the ocean, it made the ocean slosh like this. And then as it sloshed, it rolled mud on the bottom of the ocean floor, and it made those spherical type things. So they're made out of limestone. You can cut them open. Sometimes they're hollow on the inside. But if you go up there, you can, up to Osceola, you can buy these from farmers because they're a nuisance. Every spring when they go to plow their fields, they plow up these things. And so they use them for fence posts. They can't get rid of them. They'll sell them to you for $5 a piece. So go help out the economy up there. All right, we're going to take a break, and when we come back, we're going to talk about comets.